Well, thanks everyone for joining this afternoon. As Diana said, today you will be joining me to like a little story that started on a Friday afternoon that the developers love because it's end of week, almost end of day was at the time. We received something, a message on Slack from once on the startup world. No, if the CEO comes and says at channel, hey, production is down on the where the developers are, we know something is wrong and was really wrong at the time. We started looking and we started asking between us, like, did we deploy? Did we change something today? And the answer was no. So we had no clue on what was happening. We started digging and we saw that the application was running fine, the instance was fine, but the database was not. So we restarted the database and everything looked fine at the time, but something happened to the database that went down. So today we'll be trying to understand what happened on that Friday and sharing some tips on how to prevent this from happening to you. When callbacks hurt, scaling race in a large monolith. Uh, as Diana said, I'm Francisco. I'm a senior software developer here at Svitla. I'm a computer engineer and I'm also an university teacher, really passionate about writing like high quality software, passionate about object-oriented programming. This is relevant because I use this in the future, but we're not talking about this today. We want to know what happened that Friday. On Monday, we started a post-mortem meeting with all the team. We started digging on what happened. And we realized, looking at the database logs, that there was a transaction that took around 50 minutes to finish. And it didn't finish. It actually killed the database instance. So we start wondering how one transaction could last 50 minutes. That was the main question there at the time. We first thought that probably was a deadlock that was hit during the transaction, but that was not the case. And being quite blind, we decided to go back to our race application with the timestamp when the transaction started. We went to the Rails logs and we saw something. For context, this application today, it was a to-do app that every example has. And imagine a to-do app built on like 2014 that grow and grow with a lot of features. And that day, one of our early adopters, a user that joined 2014, wanted to remove his account. That was what we saw on the logs. So we started wondering what happened. So how? And user destroy started all this problem. We discovered a couple of things. The user had a lot of records on the database, and that's when our friends, the callbacks, started happening. The callbacks are something that since I started with Rails, I think I love them in general. It's like I love how descriptive they are. Like before save, do something. After saving, do something. For reference in the presentation, we are showing like all the update or create callbacks. And then we have the destroy callbacks. But something that's really powerful about them is that if something on the callback fails, the whole change will fail. So the update will not happen or the destroy will not happen. And that's when the transactions happen on the same database transaction. This means that, for instance, if we hit an API on one of these callbacks, we will have an open transaction until the API responded and we finish all that process. Sometimes this is needed, but sometimes it's dangerous. But we also have applications that could be evil as well. Here I have two examples for the, let's say, the account model. The wonderful keyword dependent destroy or dependent nullify could also be our enemies. Dependent destroy, or just for context, if someone doesn't know, will remove all the tasks related to that model, and dependent nullify will update all the related tasks to nullify the reference. This means that if one account has millions of tasks, we will be trying destroying all those at once or nullifying all those at once. This way, we are doing a lot of changes at once. So we learned something from this investigation. We learned that long transactions are dangerous and probably bad, I would like to say. If we look database documentation, for instance, MySQL, I think they recommend something like, and we were hitting like a 50-minute threshold. So we're in trouble. On the other hand, I want to also think about how the application feels. In general, all the callbacks help us to do synchronous actions to guarantee that when, for instance, an update finishes, something happens. And this usually means that the user is waiting for something to finish. Could be submitting a form, could be the delete account button. And in the UX side of things, an application will feel slow from if something stands for more than 2 seconds. And so in this scenario, we are not only risking the health of our application, we are also harming the UX from our application. So our users will be waiting really long times when there are really long relations that we need to clear or update, or even if we have really long callbacks. And then we realize something, that we are in constantly dangers right now because we know that some models can have really long trigger really long transactions, and that means our database can go down at any point, and we don't know when, we don't know who, like not only the models, like outside the code. Maybe my account is fine to be deleted, but that early adopter account was not. So it not only depends, like not on traffic, not on code, it depends on the data that the user has and the action he's trying to do. So here I like to say like a Cold War scenario. On the history books, we always read that at the time, everyone was like kind of scared that at any point they could start a war. And we were like in a similar position, but our application can go down at any point and we don't know. In the best case scenario, it happens during working hours from Monday to Friday, but it could be during the night of a weekend, could be on during the weekend, or could be even when someone is on vacation. So we need to do something. That was our gut at the time. And someone on the call said, let's take control of the transaction. That's easy. If the problem is the callback and the transaction that it's too long, let's move everything to an async job. That's it. Copy and paste. And then we start thinking a bit deeper. Does the UX handle that? Like if we show a message saying, hey, this action was successfully done, does this mean that the action was totally done? If we move that to an async job, we know that that action will happen, but was not done yet. So we ask, hey, do we need to redesign the UX across the entire application? That sounds crazy, so Probably not. But then here is another question that we tried to answer or we got at the time. What temporary inconsistencies are we willing to accept? When we speak about temporary inconsistencies, we speak about things that right now are not as expected to be, but they will be. A real world example of this, it's like if you move an event on Google Calendar, you will see that on the other calendar's participant, the event was not moved at the same time as you moved yours, but it will be moved at, I don't know, 2 seconds, 3 seconds. That's some temporary inconsistency. We know that the event will be moved, but it can happen in a short period of time. And then the PM that was listening everything, that was scared also because he wanted the application to work, asked us, hey, how long it takes to move everything to shops? He firstly thought it was like 1 week work because we said copy and paste, but those shops are not copy and paste either, because it doesn't matter if it's a callback or if it's the relation that triggers a long transaction. The problem here is the long transaction itself. If a long transaction is triggered by a job, let's say a transaction that deletes 528 billion records, we might still kill the database. So we have more questions than answers at the point right now, but let's clean everything a little bit and try to think straight. The first question that we have right now that's different from previous ones are like, how do we want to tackle the issue? We know we want to tackle it, but how? Right now we know that the user model is harmful, probably, so we need to fix that. But is there any other model that is harmful? So here it's the two. The first question is, do we want to be proactive or reactive? Do we want to wait until something breaks to know that that model is bad and fix that? Or do we want to try and go and fix every model that could be bad, preventing, for example, the application going down during a weekend? We decided to go proactive because we prefer to tackle the issue and prevent this from happening at any point in time. And to be proactive, we need to answer the following questions. Which models are at risk? Like, is the user model the only one that can take down the database? There is any callback that it's particularly harmful? All callbacks are bad. There is a way to prevent something from blow up. And also, which flows do we need to change? As we said, it's not only the application code that we need to change. Probably we will be introducing, if we go like with the async job approach that we said before, we will be probably introducing eventual inconsistencies that will be done at some point. But how do we answer all these questions? Like, which models are at risk? Do we go and read, I don't know, 500 models one by one and understand each of those? Probably most of them have, I don't know, 200, 300 lines of code. It's a really old application, take that into account. The same with the callbacks. Do we read each method? How can we do this? So trying to answer how can we be more proactive, as I said, I love object-oriented programming, and once I was debating with someone he about object-oriented programming and Rails, and he said, I hate Rails because every model inherits from active record. There is no need for a model to know how to be saved into the database and how to update and everything. And that person come back to my mind, and I was like, oh, inheritance, it's powerful. We love objects. In Ruby, everything is an object, so we can do this. We can override that the inheritance allows us save destroy methods. How? We don't want to touch Rails code because we want to guarantee that everything is saved or destroyed, but we can hook something there to make sure that, okay, let's get a timestamp. Let's understand how much time this action took. Like, we can do this. And as a result, if this works, we will be answering the question on which model we need to investigate, because it's not the same. We will know which models takes 5 minutes, 3 minutes, or whatever. Here it's one nitpick, that it's not fully proactive, this approach, because we are still getting the log or the whatever we want after something happens, but we know that it took more. Let's say we put an upper time bound on like 2 seconds. We can know that every single model that took more than 2 seconds. Does that mean that we'll take down the database? No, but it could be potentially. Here is a little snippet of code on how we can achieve this. We take the timestamp, we execute super because it's how we write the database or remove things from the database. We get the elapsed time, and then we return the result to make sure that we don't break default behavior. And here what we need to add to this snippet is something that will log which model it's taking more than, let's say, 2 seconds, or how much time it took that model to be logged. If we go with, let's say, we can send an error track to our error tracking tool, could be like Backsnack, Sentry, Datadog, whatever. We can trigger monitors, we can write logs. So this way, we can know which model have an issue and narrow down the investigation, as I said before. So we got some answers. Now it's not only questions, we have some answers. Doing that, we will know which model can blow up. We know that, let's say, the task model sometimes takes 5 minutes. It's enough to take down the database? No, but it can grow until 50 minutes or whatever. It's the threshold to kill the database. This way we are not only reducing the models, we are by consequence reducing the callbacks. If each model has 5 callbacks, now we probably need to investigate half of the models, not all of them. So less callbacks to check. And also the flows, because if we assume that there are 3 flows per model, we can say, okay, maybe the creation and the update is fine, and the problem is the deletion, because we know which flow triggered the update, the callback. And we can this way understand in our heads, okay, this model is bad, this callback is bad. And the same we did with the save and destroy, we can use those also with the callbacks for investigation when we know which model to tackle. But yeah, just one idea to how to tackle one callback itself. It's not only reading code, it's understanding how much time it took. And here are 3 main problems that usually tend to be like callbacks that needs to be tackled. I like these 3 categories in general, like transactions without limits, external API calls, and very long-running operations. We can, with each of these, we can read the code and try to understand what's happening. Let's go one by one. What means a transaction without limits? I like to explain this one with what is a transaction with limits. A transaction with limits means that there is something on, let's say, the product, the business, or outside our system that says, hey, there is a limit here. For instance, in our to-do app, you cannot have more than 10 checklist items per task. That means if whenever we remove a task, we will be removing at most 11 records on the database. Could be less, but at most it's 11. On the other hand, the user model could be have infinite tasks. As we said with our early adopter 2014, he had a lot of tasks with a lot of checklist items, but so it's an infinite upper bound. So we don't know for sure the worst case scenario. That's how we can identify an unbounded transaction or a transaction without limits. So if we know how many elements will be there, it's limited, it's fine. If we don't know and we have something like, I don't know, for each on a relation, no limits on that relation, like could be infinite, probably we need to be careful with that, because at some point when Rails scale and your application grows, that data could be worse than we think. External API calls. Here, I didn't explain external API calls. I'm not gonna lie, I just tackled more like how we can analyze those, because the external API calls, we probably know what those are. But here, what we need to think is that what are we doing with that API? That needs to be like synchronous, that needs to happen inside the same transaction. Or it's something that we can leverage some asynchronously to happen. That's the crucial point in general of this whole issue. For example, if we are, let's say we create a user. When the user is created, we hit some external API, let's say, I don't know, Firebase, because we create some authentication things. Okay, that is the case. Whenever we create a user, it needs to be created in Firebase, that's true. But whenever we remove the user, that needs to be deleted like at the same time, or could wait until, I don't know, 5 minutes, 2 seconds. It doesn't mean to be like, oh, it waits until next year. It's just a short period of time where we support that inconsistency. On the other hand, it could be some systems that don't even the creation needs that synchronously action. But here, the more crucial part, I would say, is that eventually we will be able to delete it, and eventually we will be able to create it. We know that APIs are sometimes unpredictable, so they can have more latency, can have timeouts. We might need to retry things, so that should happen outside the transaction. But the important thing here is that should happen. Our system probably relies on that from happening, and it's not a good idea to have like an orphan user on Firebase because we didn't remove it. If we go with the shops approach here, I like to say like encourage you to use retry policies. We need to guarantee that whatever we are doing, it happens. It doesn't matter when, probably. That's why we are moving that to an asynchronous job, but the important thing is that happens. I didn't put an example from retry policies because it really depends on the shop. The queue adapter that we are using could be solid queue, could be rescue, could be sidekick, but in general, be careful because we need this from happening. We cannot do any of this work and just forget that we need the consistency. And then complex operations. Operations that are naturally heavy and take several seconds. This could be doing something across the whole, I know, I just like recently I saw something that was like iterating over a lot of records doing something else and was like, okay, the iteration is fine because it's batched and everything, but it doesn't need it to be happening inside the transaction and it could be removed. And that took a lot of time. Here it's like, again, what's complex? And in general, what can we do with all these three? Like, there are two ideas here. The second one that's on the slides, that's the first one I'm talking about. Move the operation outside the transaction. That's the first thing. Like, maybe you don't need a callback. It's nice, but you probably don't need it. And you can do something like user service creation and move that piece of code that was done by the callback inside that class, or even the controller. But in general, try to, okay, remove the callback, move that piece of code on like the controller and try to do that. That will make your transaction shorter and probably you will be able to handle the problem. And there is another solution that's the one that I usually preferred, but it's a bit more complex. It's not just copy and paste. Asynchronous jobs. As I said earlier, when that developer on the call, on the postmortem call said, hey, let's move everything to async jobs, we were like, okay, the job, it doesn't matter. The important thing is the transaction size. So we cannot have a job that delete n task, infinite task. It needs to be batched, and we need to do that somehow. Here are two examples. These are two like in-house solutions that we can use. Quite similar, quite simple, honestly. It can help you to get on the road for this. The first job, it's okay, let's get all the checklist items where the task ID is task ID in batches of 500, and we remove each batch. We remove every checklist item after this job finishes, and we have all the information that we need consistent. Be careful, because as we are seeing this job, this means that those checklist items will be living inside the system until this job runs. And we probably don't know how much time we have for that job to run. The other part could be a bit different. Like we get all the IDs, we get batches of 500 IDs, and we call some other job that will do the removal. The main difference between these two approaches, the first one happens at once, between quotes, because it means that we are whenever that job finishes, all checklist items will be removed. On the other hand, we can do this quicker maybe, because we have like 5 jobs that are removing each one 500 records. So there are two approaches. I personally don't have preference between the two, but that's two ideas on how we can try to batch those jobs. But there is some other solution. Not so in-house. Sometimes when we come up with in-house solutions, we are missing edge cases. Whenever we are working with Rails, we are talking about scale. We probably know that Shopify is really good at running Rails at scale, and they have really nice tools to help us doing these kind of things. Shop iteration, it's a gem. Build it. Shop iteration, it's a gem built by Shopify that will allow us to do what we need. Run batches of things, and this will allow us to remove all the records we want in batches. there are two methods in general when you look at show iteration. The first one, build the numerator, is how we are building that relation. So in this case, we want to iterate over all checklist items in batches of 100. And each iteration is like the perform or the context inside the block on the previous slide. Here we are saying, okay, each iteration, you have a batch of things, do something with them. I really was using the destroy kind of thing, but this approach will work with any other action that we need. For example, if you need to nullify some IDs, you can here call a service that will nullify, well, update something that will nullify those columns, or a service that nullifies those columns for you. If you need to call an API, you will be able to do that here. First question, does Ruby on Rails give some instruments for profiling code? It does. We have some sort of tools, but in general, we end up doing that on how I showed before on the first slide, like running like timestamps. That's the best way for these kind of issues, since it really depends on the data that you're profiling. Like you really need the production data for this to work, because it depends. It's the main issue here, it's the data. So if you have so much data on the user, that means that your task will take a lot of time. Could load balancers advance increase transaction possibility of overloads? I'm not so sure. Probably yes, but you are still on the same problem where you don't know. Well, you know. Oh, that's a good one. I didn't thought about that one. That's a good one, not gonna lie. If it's possible, I don't know, honestly. And there was a second evil on this story, that was the relations. When we have huge relations, we can also be running into problems. But Rails already fixed that problem kind of for us. That's why I ignore them until now. There is a dependent different from the dependent destroy. Destroying will destroy the records in an asynchronous way. You have yourself a job, right? Provides a job that works with batches and everything, but you are not tied to that. If you want to introduce your own retry policy, your own error handling, your own exceptions or whatever, you can configure Rails to use your own job. That means that you can write your job with the configuration I just shared there, and it's easy for you to understand, okay, let's use this retry policy, use this error handling, and all the customization you need. If you want to use show iteration, for example, you can create your own job that use show iteration for this destroy async. The second, aren't you trying not to delete records, but to add a column for existing, just Y or N? Deletion is very cost operation. Aren't you trying to not delete records, but to add a column for existing? I'm not following the questions. Oh, you mean, okay, you mean soft. Yeah, the chat is going. I believe in general to go with soft deletion is a good starting point for a large system. That's true. Sometimes the issue that we found, at least I use deletion for the example, but most of our problems were coming from updates in general, where an update took a really long time because was also updating maybe so many records, was doing so many things. And this way we could profile the problem until we find the root cause. That was it for me. Thank you so much for hearing. We were doing Q&A in the middle right now, but if there is any further questions, I'm happy to focus on those now.
Hi everyone again. So sorry for the chat. I didn't know that the settings, I don't know, is either it's Zoom or maybe other teammates. The settings were just changed and the chat was closed, but I opened this now and I'm happy that now you can write your questions in the chat. We have a new question, two or three. Oh my God. But before that, I just want to remind you that if you want to talk to us, I can just, you can just push the raise hand button and I'll also unmute you so you can talk to us. But we have three questions new already. So Francisco, the stage is yours. But if you want to talk to us, you're very welcome as well.
Is there a way to parallel processing in order to divert those time-consuming updates? Yes, but you still need to run away from the callbacks because the callbacks by themselves will run inside the same transaction. And the way you can do that is, as I said, move the code outside the callback into an user service or a controller or wherever you want. And that way you will be able to parallel process the data and prevent the transaction to be too long. Do you have any issues with queues balance loads? You mean on the jobs or what do you mean? I don't follow the question, sorry. Eugene. Oh, okay, on the jobs. We had some problems right now. We have a really good structure on different queues and different SLOs on the queues. So we have different resources on each queue and different workers to prevent this kind of issues. So yeah, that's a topic I think for a whole other talk. But if you have different queues and you have a specialized worker for those, you can prevent this kind of issues and you can configure which queue you need your shop to go. If it's something that it's really important to happen in between seconds, probably you need a highly specialized queue with a worker that can handle that kind of actions. And maybe if it's not that important, you can move it to some other queue and wait some more minutes. But it's more like an infrastructure thing and solution rather than how we tackle the issue on the code on the Rails application. Did you encounter any problem with transaction binary log on databases side? Not that I'm aware of. I don't think so. Maybe we have, and I don't remember because all this story happened like quite a long time now. But yeah, no, not that I remember. Oh, okay. Maybe that's why I don't remember or didn't realize. Um, so, well, that was a chat. I don't know if anyone raised his hand or her hand.
No, we don't have any other raised hands. I mean, we can wait for a few seconds for new questions to appear. Yeah, we have one raised hand. Just give me a second. I will unmute you. Just give me a second. Volodymyr, hello. Please unmute you and you can talk to us.
Okay. Hello. Thank you for a really interesting conversation and actually a talk. But I see that you have a callback in a Rails system, and I believe it's kind of legacy, so you should deal with it. But now, when you wrote a new code, is to why the usage of callbacks is like a good pattern for you, or you try to omit it as much as possible?
I think now, after all this experience, I try to think case by cases in general. As I said, I think callbacks are powerful and I like them. So if it's something that it really goes there, I try to use them because I think it's a tool, it's powerful, but I think we should use it like really carefully and try to prevent those obvious things as API calls inside those and try to think ahead and like, okay, can this be an unbounded transaction and this will grow? Those kind of questions I try to answer before following the pattern or not.
I see. Thank you.
No problem. There are nasty situations with async data and data consistency. Did you encounter anything interesting on that side, maybe? Sorry if it's on the spot. There are some. We found like for now, usually all the problems we fixed, there were like the application supported, I would say almost always the asynchronous pattern, and we didn't find any major problems. But there are some that we found in the past. For example, we really need to deep dive into application because we found, for instance, I remember someone that we were nullifying some references and we were like, okay, we are not sure how this is handled at any point because it was also outside our domain. But in the end, after a lot of investigation, we realized it was nothing nasty that we couldn't handle outside the asynchronous and data consistency. Again, I think it's something really important that we should think about, but for now, I don't have any nice tip or experience to share around that, for now at least.
So, okay, it feels like, okay, we have new question. Do you start a project with Rails nowadays still?
I do. I'm really Rails enthusiastic, honestly. So yeah, I still start my projects with Rails. But I think that's more a personal opinion rather than a technical one. So yeah, I do. What's your opinion on Ruby 3 types? Anything related to types, I don't like it. Personally, I like to be dynamic typing. I think that's one of the most powerful things, also dangerous because you need to be careful when you use them. But if you know what you're doing, I think it's nice to be dynamic typed. And also in the big project, we are not using types at all. No problem. Love to chat with some other people. Yeah, I think we will probably take a look to that the next time we need to fix a deletion issue. We can take a look to that. Yeah, totally. What's the size of the database updated removed rows when you start seeing 50-min transaction issue? Is it possible that AR deletes rows one by one? This it's I don't remember actually. Though was an exaggerated number, but was really long transaction in minutes. But for example, was something with was the call the how this ended up working, because we might be seeing only one, but the real problem ends up being like a cascading thing. Like maybe the user had 10 tasks, each task had, I know, 10 checklist items, and then that starts growing so much and the user ends up taking so long. So sometimes the issue is not only on the user with a million tasks, it's maybe the user that has 10 tasks and those 10 each have 10 other things. And that's how that grows massively, and you go easily go to like hundreds of thousands, probably something like that. Um, it's not as simple as it sounds for large apps, true. You could do it manually. We can, but there are a lot of records, so we don't usually do things manually. Oh, you meant that. Sorry. I mean, uh, I mean, yeah, that was one of the solutions, but we need to analyze everything that we said manually with, sorry, I forgot to read the question. Manually, I mean, crotchers at maintenance time. So we need to be careful that we don't have any data that we cannot remove. Do you expect this problem might present different when working with SQL and non-SQL? I would say yes. I'm not an expert on non-SQL, but I think the main issue here is that SQL databases follow like the ACID properties, like atomicity, consistency, idempotency, I think it was. And at the end, we try to do that. So I'm not an expert on databases, but we try to do that in the transaction to prevent any change after all the changes are done. And that was really costly. And I'm not so sure that this will happen on a NoSQL database. Probably will face other issues. But I'm talking without knowing, so I could be wrong. I think that speeding up is possible, that just crafting query by hand can fix issue. 50 min even for it's extremely long time. It would be interesting to see actual generated query. Yeah, that's something that needs to be looked for sure. Again, I'm talking about numbers by heart and my memory is not the best. But the issue was like really big applications with really entangled uh, callbacks that call multiple things at the same time. We have seen, I don't remember 50 actually, but the most we have right now, I think it's around 28, the longest we saw recently. Didn't cause an incident, but we saw 28 minutes. It's easy if it's chained queries. MySQL, it's sometimes weird. Yeah, also on large databases, sometimes the index selection, it's weird. So those kind of things end up being like really tough in general.